Hello, good morning.
Good morning, Jad.
Good morning. Okay, we'll go for VDO today. VDO stands for Virtual Disk or Data Optimizer. Virtual Disk or Data Optimizer. This is again a preview feature available in Linux 8. Okay, so this is again a preview feature. I'm teaching this because just understand the technology and you will have a question in exam. That's the main reason. You'll have a question in exam, so you must solve it. So that's the main reason I'm teaching this. So this is a matter of half an hour, maximum 40 minutes. Let me just explain underlying technology of VDO. So this is again application-based storage. This is app-based storage. So we must call VDO volume, right? Application-based storages are called volumes. Operating system-based divisions are called partitions. We have discussed once. So this is an application-based storage. And you don't have to install this application. It is default in every Linux operating system. It is default in every Linux distributions. Okay, so application name is VDO. You can check it. You just come back to machine and check. Just to say like rpm-q VDO. It says VDO application already installed, so no need to install it. It's there in machine, every distribution. So what this technology, what's the advantage of this technology? What feature this technology is offering? VDO has two features. Stratis had two features, remember. Disk pooling, file system snapshot. Okay, so those two features we have discussed yesterday. So this VDO also has two features. VDO also, okay, have two features. First feature is, before that, let me just connect one pen drive. I just want to copy some data for testing. Okay, please wait for a moment. Please wait for a moment. Okay, so there are two features. First feature is data compression. Data compression. So you know what is the use of data compression? We don't have to learn how exactly the technology works. That is really different. But you try to understand what is, you might be knowing what is data compression. So compression is a technique or, okay, technology used to save the disk space. That's all. That is data compression. So I think I don't have to explain more about data compression because we have used so many compression technology. If you really would like to know how exactly compression technology work, there are different types of compression technology available in market. Okay, different different compression applications, data compression applications follows different technologies. So if you learn anyone, you can really understand how exactly this technology work. Okay, but second one is data deduplication. This is what second one, data deduplication. So these are the two important features of the VDO. VDO has two features. VDO offered provide two features. First is data compression, second is data deduplication. So these two technologies are really used for optimizing your storage space. So that's the reason we call it as data optimizer, virtual disk or data optimizer, because you're using these custom compression is really used for optimizing the usage of the storage space, right? Data deduplication also for that, but I'm just going to explain data deduplication. It is a bit difficult to explain, listen well. Okay, compression, forget, you might be knowing it. Windows operating system has native compression. Okay, if your file system is NTFS, HPFS, it supports native compression. Native compression means you don't have to use an external application for that. Your operating system, file system itself has the feature to compress the data to save the disk space. You might be knowing it. But in case of Linux, there are numerous applications available in market, numerous technologies available in market. Anyway, if anybody planning to use VDO, they'll use only in data centers or enclosures. That is the place where we want to optimize the usage. Okay. Now let me tell you what is data deduplication. This is really not new to the market. It's very old technology. Okay, I've heard this technology in 2007. Okay, it's very old technology. And it was there in market in 1990s, I think, really. So it's not new to the market. Data deduplication technology is not new to the market. And this technology is available in, nowadays in most of the most of the operating system has this inbuilt feature, data deduplication. Linux has Windows 2008 server, 2012 server, 16 server, 19 server, 2021 server, all server operating system from 2012 above all server operating systems support data deduplication. And you also please try to understand, okay, most of the storage management applications, storage device management applications like NetApp, Spectrum, all are really supporting this. So please try to understand this is not new to the market, this is very old. And what this technology do, it is really difficult to explain. Please listen well, okay? Okay, now data deduplication is a technology used to ensure storage space optimization. Storage space optimization to ensure optimum use of storage. Optimum use of storage. And there is very important data science work behind this. But we are not going to discuss that. I'll just try to make you understand how exactly it works. Okay, so I didn't tell you what is that. Listen well. So imagine you have a hard disk drive. This is a partition. Okay, this is a partition, hard disk drive partition. Size of this partition is 100 gigabyte. 100 gigabyte. So you have stored a movie here. Okay, one example, one movie. Size of movie is example 2 gigabyte. Example 2 gigabyte movie stored. So what will happen is it will utilize complete 2 GB space, right? So you have remaining 98, right? Out of this you have 98 GB now. Only 98 GB is available. And you're going to store this movie, duplicate copy of movie. Duplicate copy of movie. Movie means you're going to copy and paste the same movie once again. Okay, example. You're going to copy and paste. So this is another copy of same movie. Okay, again you have kept one more copy. Okay, again, okay, you are just copying. I mean, you're copying same file multiple times. Listen, how many times? Example, you have stored this particular file 10 times. 10 times. Let's see. You have stored this movie 10 times. What's the size of movie? 2 gigabyte. So 10 into 2 equal to 20 gigabyte space will be utilized, right? Now you have hardly 80 GB of space. Okay, you may have a question, no, Ashraf, who will do this? I know. But you just imagine there is one public storage, example, okay, torrent. And okay, 100 people are uploading a particular movie, same movie from different part of world. no one knows each other. Okay, so what will happen? Same movie, example only. Okay, uploading or downloading, that is different subject, but try to understand. So there's a chance, right? So what will happen? Everybody uploading to same storage, torrent storage. Example. So what will happen? Okay, 100 into 2 GB, 200 GB of space will be utilized in storage. You just imagine, storages are really precious. Storage space is really precious. Okay, so if you want to understand the cost of the storage, you must approach cloud for storage space. Then you will really understand, you can realize cost of the storage is really more than a VM. Understanding? Because okay, storage will have a lot of different technologies will be used for fault tolerance, failover, many things. Understanding? Okay, what you will do is you will just reserve you will just buy some space in Google Cloud or Azure Cloud, and you will have so many demand. First demand is my data should be available 24 hours 365 days whenever I'm okay trying to access. That is one demand. Second demand is, okay, my data should be available, should not say like lost or something. So, right? Okay, to ensure availability, we must go for, okay, for, like a technology which ensure the, like, 20, it's available always. For that, we must go for clustering. Clustering is really huge. And also to ensure your data is safe. So they should take regular backup. So they might be doing this in background. That's the reason they are giving 100% guarantee. Understanding? So these are really costly. Cluster administrator, so many machine. Okay, backing up, regularly, automating it. So it's costly. So okay, we are thinking storage means just a storage which we are getting. Okay, for end user it's just a storage. But in background, so many functions are running. That's the reason your data is available always. And okay, you will not lose your data also. Understanding? So what I'm saying is, look here, this is just an example to understand. Like this, 100 people upload it. So what will happen? Okay, but try to understand, okay, file is same, movie is same. So you just imagine what is the use of storing one movie 100 times. Okay, will you store in your personal computer? No, no one will do that. By mistake, okay, we may like, it may happen 2 copy or 3 copies, but 100 copy will not happen. So this is just an example to understand. So, okay, how to overcome this kind of situation? Okay, torrent cannot hire two, 3 employees to, okay, find and delete duplicate data. That is impractical, right? Okay, you just imagine torrent is hiring 2, 3 employees and giving this job. They have to find all duplicate files and they have to find duplicate file. Duplicate file means not only the file name. File name may be different, but content can be same, right? So then you have to just open and watch. Then only you will come to know whether movies are same or not. Is it practically possible? No. Understanding? So like then you can tell us stuff. They could develop some application. You forget it. This is all I'm saying just to understand. Imagine this can happen really. This kind of situations we will face in huge storages, especially very big company storages and all. We may face this duplicate data is big problem. Just imagine. Okay, we are supposed to keep only one copy. One copy is enough because files are same. Instead, 10 copies are, by mistake, 10 copies are created. Then what will happen? You are losing almost 18 GB of space in place of, okay, 2 GB you are using 20 GB. Understanding? So 18 GB of space you are losing. 18 GB is really huge. Understanding? So how to overcome this kind of situation? There is no chance to happen this type of things in our personal computer, that is for sure. But it can happen in, okay, general storages or big enterprises network storages and all. There's a chance to happen this. So that's the reason data deduplication technology is developed. I don't know who exactly developed it, but I've heard it was there in, okay, EMC storage from 2003. and it was there in market in 1990s. I've heard like that. I don't know the reality. Okay, but it is there in every technologies now, every storage application now. And what is data deduplication? Look here. So this is the partition. Okay, first example. Let's take another example. I have another partition. Size is 100 gigabyte. Same like okay, like this 100 gigabyte. And I'm going to apply data deduplication technology on it. I'll apply data deduplication. So this is what a partition which doesn't have data deduplication technology, but for this partition I'm applying data deduplication technology. Okay, so we call it as a deduplication technology. Deduplication technology is applied. Okay, example, deduplication technology is applied. So when you apply, this is 100 GB, right? When you are applying data deduplication, what will happen is some changes will happen on its file system. Some changes will happen on its file system. What's the changes? You see, 60% of the, okay, sorry, 40% of 40% of the disk will be reserved as UDS area, 40%. So this is a total 100%. So in this 40% of the disk reserved as UDS area, UDS, okay, area, and remaining remaining 60%, okay, technically called data area. Don't think beyond. Okay, if you are thinking beyond, you will be in trouble. Okay, just listen well this. I've told you these are the two chapters. Okay, bit tough. Stratis, we had finished yesterday. Second video, that's all. Remaining all chapters are really easy to understand. Data area. So data area is to store data, regular data, and UDS area is to store duplicate copy of the data. So also you please try to understand. Now disk is ready, please. Disk is ready. Okay, so sorry, partition is ready. 100 GB in size. 40% is reserved as UDS area. Remaining 60% will act as a data area. These are technical terms normally used in this, data duplication. Now I'm going to store this 2 GB of data. Okay, I'm just going to store 2 GB of movie here. I'll move 2 GB movie here. You know what? Last time we had stored 2 GB movie on a disk or partition where data duplication is not applied. But this time we are we are storing on the disk where we have applied data deduplication. So what will happen is when you are storing example, when you are storing a file, it can be movie or a text file or songs or whatever it may be. That's not problem. That's not a subject. Okay, what will happen is your data will be divided into bit streams. Okay, that is done by data deduplication technology. So this technology will divide your total data into small bit streams. Understanding? Let me tell you an example. Okay, this is total 2 GB movie that will be divided into so many streams. Please do not ask me how many streams. I can't tell that. That is really okay. Depends on this algorithm. It's using okay, special algorithm for that. So one example. Okay, this is divided into small bit streams. Okay. Okay, example. So this is the data. Listen well, please. It's difficult, please. This is the data divided into small bit streams. So how many streams we got? I'll just draw, and then you will understand easily. Okay. Example. This is one bit stream. This is another bit stream. Like this, small bit streams. Okay. So please don't ask me 2 GB. Okay. 2 GB of data. How many bit streams will be available in 2 GB? That is really okay. Algorithm decided. Okay. So these are the streams. Like okay, in each streams you can see there are some datas. So in first stream there is A, B, C, again A, okay, again B, E, okay, E, D, again A. Example. So here you can see there is duplicate stream, right? Because in computer science, okay, I mean data science, we learn one theory, that is, if you take any, okay, any huge amount of data and divide to bit streams, that will have duplicate, 100%. 100% that will have duplicate, okay, bit streams. That's all. We don't want to dig now, just to keep in mind. Okay, if you take huge amount of data and divide to bit streams, okay, you will have so many equal bit streams, that is for sure. Keep in mind. So here we have so many equal bit streams, right? We have so many equal bit streams, like A is 1, okay, again A is, okay, there is B, understanding, there is again A, so there are equal bit streams, means duplicate streams. You know what this data duplication do? It will store duplicate streams only once. If there is duplicate stream, that will be stored only once. So look here, this is a special place for storing duplicate streams. Okay, this is a special place, UDS area. Okay, so when you store data, what will happen is the data will be stored in data area first. Okay, until it divided into bit streams. Once divided into bit streams, what will happen is, okay, it will just do the segregation. So what will happen is, it will just take, it will find duplicate copies. So this is 1, 2. So okay, this particular stream is actually, so means what, repeated, right? So it will delete. Okay, equal bit streams will be stored only once. So this also will delete this problem. Okay, delete it. Okay, and there is A again. So I'll come here, I'll just delete A. Okay, so there was 3 times, A 3 times. So what happened is, we have deleted. Okay, now A will be stored. Okay, it will store A here. Now you see these space. Okay, these spaces are free, right? This space. Okay, this there was here somewhere, right? Okay, all are free. Okay, 1 second. Okay, anyway, so A is stored here, and what about B? B repeated. So there are 2 times. So B also will be stored here. It will store B here in UDS area. Okay, and here also we have B. B will be stored only once. So it will store B here. And what exactly it do is, it will just refer. It will just refer these values from, okay, UDS area to data area. Just a reference. For reference, we don't need space. Okay. So B, understanding, B here. We had B here. Okay. Sorry. Yeah. B here. A was here, and there was A again. Multiple location, right? So it will just use, okay, reference like this. This is an idea used for it. Okay, same way. Okay, so B also again referred to. B is referring here. So for referring, space is not required. So finally, okay, again, I'm going to store same, movie once again. Then what will happen? Same thing will happen. So what this movie will be divided into bit streams. Understanding bit streams, and also you try to understand. Okay, so last time how we had so many streams, same stream will be available here also, because same file, right? So finally what will happen is, okay, what will happen is, listen well, like all stream data will be available in UDS area, because after dividing this, okay, after dividing this also you will have, remember previous, anyway. Example, look here, A is available here. So what will happen is, it will remove A from all A from this particular all, okay, stream. I mean, A stream data will be removed from, okay, this data area. So that will be free. B is available here, and B also will be removed. So it will refer from here only. Understand, UDS area. C is available here and here. That's what I said. Okay, so when you're storing data, what this data deduplication technology will do is, it will first divide the data into equal bit streams. So I mean, like, it will divide the data into bit streams, and it will just, check, it will just, compare the streams with an existing streams available in data area. And if it is, matching means duplicate, it will store only once. So then immediately that duplicate, okay, stream data will be moved to the UDS area. From there it will just refer. Understand? Finally, suppose you have stored 10 times. Example, you have stored 10 times. 10 files will be available or visible in data area, but that will not contain, those will not utilize space, because, okay, all streams are equal. Complete streams would be available in UDS area. From there, it will just refer to the, okay, means appropriate file. Understanding? Finally, you can see you have stored what, 2 GB of movie. Okay, you have stored 2 GB of movie 10 times. Example, 10 times. Okay, it will use less than 2 GB of space. Last time, okay, 20 GB space was used because we didn't apply data deduplication technology on this. But here, data deduplication technology is applied. So, okay, it will work in different way. I've told you, like, the moment you store a data, it will, okay, it will divide into bit streams, and equal streams will be stored only once. Also, it will, okay, compare with existing file streams. Okay, streams are the same, no use of storing it, okay, multiple times, right? So, and it will refer from the UDS area. Okay, stream data will be referred. So finally, you have stored this movie 10 times. Example, you have stored this movie 10 times. Okay, so it will utilize less than, okay, less than 2 GB. Even it is not taking, okay, complete 2 GB, because size of the movie is 2 GB, but it's not even taking complete 2 GB. Reason, after dividing, after, streaming the data, there was duplicate streams. Duplicate streams will be stored only once. And also, the main advantage of this technology is, when we are saying it's taking time, but this work faster. Really, they have used, they have developed very efficient algorithm for this, so it's really fast. You will not even feel any differences while accessing. What I'm saying is, you have stored 10 times, but you can see less than 2 GB space is utilized from this. Okay, this disk, less than 2 GB, but all 10 copies will be visible on your hard disk. You have stored 10 times, right? All 10 copies will be visible. All 10 files will be visible. But it's to, okay, utilize less than 2 GB, because, okay, all files contain same data. After dividing all files into bit stream, there was, okay, equal bit streams. Equal bit streams are stored only once. Understanding? And it will store in UDS area. From there, it will refer to the original file. So reference, that is, for referring, it will not take space. Okay, storing data only will take the space. This is what data deduplication technology. And if you want to understand more, because this is really used in, okay, 99% storage application has this facility. Example, in NetApp, we have used it. Understanding? NetApp application, we have this, and all will have, data deduplication, because this is really very important for, about an organization, because in an organization, there's a chance to happen these kind of problems like duplicate data. Understand? Also, you try to understand, this is not only covering duplicate data. So when you are storing data, it's not checking whether duplicate or not. It's just checking only one. Okay, it's just doing only one thing. What? It will divide the data. Okay, example, let me tell you one example. This is one movie, this is another movie, and size 2 GB each. But if you, okay, if you divide this movie into small bit stream, there is huge chance for duplicate streams in this case also. Last time we have discussed, same movie, right? But now you take the case of different movie. Okay, according to data science theory, there is a chance to get so many duplicate streams in this case also. So that's the reason I'm saying, okay, what? It will use less than 2 GB only. Just imagine, it's like you're storing, you're storing 20 GB of data in 20 GB of data in place of, like less than 2 GB. That's really good technology. So this is really, like optimization technology, storage optimization. This is used in, especially in virtualization, everywhere. Let me tell you one example. Listen, I have three VMs here. Everybody know. We all have three VMs, right? I have three VMs. All three VMs contain cent operating system only, and this all three VMs will have a virtual hard disk. All three VMs virtual hard disk store in document in virtual machine. See, server B workstation. See how much 80 GB of space utilized on this workstation. Machine utilized 18 GB of space in my C drive. This Okay, 9 point means 10 GB. This is, again 12 GB. Almost 18 plus 12 equal to almost how much? 40 GB, sorry, 30 plus 40 GB space is utilized in my C drive, because document directory is available on C drive, right? Document directory is available on C drive. Almost 40 GB of space utilized only for this virtualization. You try to understand all three machine. All three machines contain same operating system. What? CentOS. So, means what's the meaning? All three machines hard disk contain same data, right? Same, because CentOS, but it's utilizing space. If I could, if I could, like optimize or apply data deduplication on C drive, I can really save a lot of space, because all three hard disks contain same data. But we want to store like this because these are three different VMs. But if you apply data deduplication on C drive, if you apply data deduplication on C drive, you can easily manage this. You can optimize the size. But problem of, server operating system, is, we have data duplication here. Okay. We have data duplication in Windows also. What problem is, you cannot apply Windows server operating system doesn't support applying data duplication on C drive, root drive. That is a problem. Otherwise, I could save a lot of space. Understanding. So that's what I said. This is specially used in virtualization. In your office also, you people might be using VMware, ESXi server, and you may create, maybe like, 50 or 100 VMs, and all VMs may contain, same, maybe same or different OS. You just imagine there are 50 VMs, and 50 VMs contain same operating system, and every VMs will utilize, every VM is utilizing 10 to 15 GB of space, because every VM will have individual hard disk. So if you can apply this technology, you can, save a lot of space. That's advantage. Here data duplication is not installed. You must install data duplication first. Okay, so there is data duplication in this also. Okay. Data deduplication. Saves disk space by storing single copy of identical data or volume. Single copy means, understood, right? Single copy means one copy only. How the technology works? That is, as I said, UDS area, streaming, understanding. I mean, like making, bit streams. Anyway, this is what two important technologies, powerful technologies work behind VDO. Understand? So we are just going to do this practically. Practically is really so simple. And next we have to test also. I'll test it. We will test it. We will test, space utilization after storing duplicate data. So this is really one important, interview no one ask, I think, but very important exam question. Exam question. I'll show you. Very important exam question. Create a video volume. Understand? So there is exam question. So that's the main reason I'm teaching this. So let's try this. I've told you VDO technology is already used. I mean, this application is already used, so I don't have to install it again. Already installed. So we don't have to, we don't, okay, no need to install. So now I'm just going to show you how do we deploy this technology in this machine. So also you can check the status of the service systemctl status VDO dot service. Yes, its service is running. It says exited. I'll tell you why it is exited, because we didn't create any video volume. That's the reason. Okay, exited. Now video application is installed and it is running. Now we can create video. Okay, disk. What I'll do is, to create video disk, you can use either block device. Block device means entire hard disk drive, partition, or LV. So you know what is the advantage of using LV? You can extend and shrink. Understand? Okay, now what I'll do is, I'll just add a hard disk to this machine. I just want to add a hard disk drive to this machine just for practicing. I'll add 10 GB of hard disk. Okay, you can add 20 or 100, it's not a problem. I'll add 10 GB of hard disk. Okay, I'll just do LSBLK. You can see one hard disk is available. Okay, there's a superb explanation available in Microsoft website for data deduplication. Okay, very good explanation, animated. Okay, animated, so easy to understand. Same thing what I explained. Okay, even I learned from that only, because Red Hat textbook explanation is not really difficult to understand. So there is a hard disk added. This name is SDA. This name is SDA. So size of disk is 10 GB. I'm going to use block device for forming video, creating video volume. I'll use entire SDA hard disk for creating this volume. Okay. So I'll just say, like, I'll just give a command VDO. I think there's a command to list video list. Yes, video list. It's not listing any video. So we didn't create yet. That's the reason. No video disk or volume exists. So we're going to create first volume. I'll just say like video create, and you have to give hyphen name of the video. You can give anything. I'll give video 1. Okay, but normally in offices we'll have some standard names. Video 1, and I'll just say like hyphen device. Okay, device equal to which device? Okay, we are planning to use what? Block device. If it is partition, you have to give partition name. If it is LV, you have to give LV absolute bar. If it is a block device, in our case we are using block device, so I'll just say like device dev SDA. This is what we are going to use. Enter. Okay, you've just mentioned name of the video and which block device you're planning to use to form this a video. So creating video, starting video, done, created. So after creation, it will restart the service, applying compression, and data duplication also might have applied. Look at this. Okay, so video is created. What's a video name? We have given video 1. Okay, so what is mapper? I've told you yesterday, mapper is a special directory, okay, created to keep application based storages, nothing else. It's a directory. Okay, so under dev it will create a directory, special directory to keep the video. For status also even it created. Understanding? So video 1. Now what I'll do is, video is created. I'll just check again video list. It says yes, there is a video exist. Name of the video is video 1. So video volume is created. What is next? We have to apply the file system. Okay, yesterday I've told you, status support only XFS, right? But this support any. You can use any file system. Okay, that's your choice. I'll use ext for file system. Let's try. I'll give a command mkfs -t. Okay, and I'll just say like which file system ext for file system. I'll give hyphen K to happen, hyphen capital K to happen the, file system creation as soon as possible, to happen fast. Okay, and I'll just give the name of the video. So name of the video means you have to give the absolute path mapper. Okay, video one. You have to give the absolute path. So you know what is MKFS, you know what is hyphen T, you know ext4, you don't know what is K. I've told you K is just for, okay, quick format, that's all. Slash def mapper video one is the device name. Happen quickly, and I'll just give a command blkid. blkid will show you file system. It says SDA. It's video. Understanding video. And look at this SDA. Okay, ext4 file system is applied. Just to give lsblk now, then it says yes, SDA disk is used for video. And it should be 6 GB, right? But showing, sorry, it should be 10 GB, but showing 6 GB. I've told you, out of 100, 40% space used for UDS, 60%, because when you are storing data on the disk where you have applied data deduplication, okay, there is a chance for so many duplicate streams. Probably the duplicate streams will be stored in a UDS. So complete, you can really, in net, you can use complete, 10 GB. 10 GB data can be stored in this. More than 10 GB data can be stored because, okay, more than 10 GB, because duplicate, when you store data, the data will be divided into bit streams. Equal streams are stored only once, right? So you can really store more than 10 GB. Understanding? Anyway, here is showing 6 GB because it will show you only the data area. That's what I said. It's actually 60-40. Understanding? 60-40. That is preset value, preset, ratio. Now done. Okay, video created, formatted. What is next? We have to mount it. Mounting should be permanent. I'm just going to mount permanently. Before that, let me just create a directory here in OPT or MNT, anywhere. I'll say like VDO, directory name is VDO, capital. Directory is created. Now I'll just go for /etc/fs tab to create an entry in, okay, mount entry. Okay, you can create anywhere here, it's not a problem. I'll create last only. Okay, first you have to give the device name. Device name is here, it's a volume, right? So /dev/mapper/video1 is that, okay. And what's the mount point? Mount point is /opt/video capital. And what's the file system we have used? ext4 is a file system. And what is, okay, mount option, is there any mount option? Yes, there is mount option. We had mount option yesterday, remember, right, for Stratis. Same way here also you have x-system d dot requires equal to, okay, what, video dot service. Okay, I've explained Stratis well yesterday. You please try to understand. We are creating an entry in FS tab. FS tab entries are mounted while booting, but this is application based storage. So, okay, so this application will start once boot process finished only. So here your machine is trying to mount these entries before starting video service. Probably it will fail. So we are just requesting system D process. I'll teach you in next class, system D, system daemon. We are just requesting system D to start video.service. Video.service. So that what will happen, while booting, your machine will try to mount, right? That mount process will happen, okay, properly. Otherwise, it will throw an error. Okay, next you have to give, okay, how you want. If you want 1 or 0, whatever, you can give. Okay, this is explained well. If anything, should ask. Should not tell tomorrow I didn't understand, he didn't teach or something. Should ask now. Okay, if anything. Save. Saved. Now what I'll do is I'll just say like mount hyphen, okay, before that check df hyphen th. Okay, no, it's not showing. I'll just give mount hyphen a for mounting all. Now check df-th, then you can see video mounted. Okay, mounted ext for file system. Okay, some space is used for file system metadata. Earlier it was 6 GB showing 5.9, 24 MB is utilized for file system metadata. Okay, and opt video is the mount point, so it's created well. Now you have to give a command video, and there is video status. Okay, video status hyphen human readable. Okay, I forgot that command. There is one command to know the hyphen human readable. Look here, this is a device, 10 GB total size. 4 GB used means UDS area, forget. You try to understand, you can store more than 10 GB, don't worry. 40 GB. Okay, it says 4 GB is used. Okay, available 6 GB. Understanding. Savings 99% because we didn't store any data, that's the reason. Now what I'll do is, we want to test it. I'll just connect a pen drive which contain a directory. I have connected a pen drive. I just want to access a pen drive from my server, a virtual machine. If you go for this option, you can access from your, okay, host. Host means physical machine. I want to access from, okay, when VMware is open, VMware will prompt like this. Okay, I want to access from server A. Give OK. Now, I'll just give lsblk again. Then you can see there is one extra disk added, not added. Okay, check again. Why it is not added? I don't know. Let me just remove and connect again. Yeah, STB, showing STB. STA is what video disk, STB is actually pen drive for 16 GB, see 16 GB pen drive. So what I'll do is I'll just mount it. Okay, I'll just create mkdir slash opt. In opt I'll create a directory called flash. Created. I'm just going to mount. I'll say mount slash dev slash stb stb1, right, partition slash opt flash mounted ls slash opt flash. Okay, so there is a directory called rhce. I'll check what is the size of it. Okay, I'll check what is the size of this. Okay, rhce directory. How do we check? Du hyphen h. Du stands for disk usage hyphen h. Okay, human readable. We have used this command, and I'll just say like slash opt flash rhce. Okay, size is 200 MB. 200 MB. So this is actually 200 MB. But when you're going to store, I'm just going to copy this rhce directory to my video disk. What's the size? 200 MB. But this will be divided into bit streams, and equal bit streams are stored only once. Even this also. Okay, so what will happen is it will use less than 200 MB on your disk, because I don't know how much. After storing only we can tell how much is used. Anyway, now I can tell it will use less than 200 MB, less than 200 MB. So let's try this. I'll just try to copy this. Okay, now just ls slash opt video, sorry, capital VDO. There is nothing, lost and found directory only. I'm just going to copy this rhce. I'll say like cp hyphen arv, okay, slash opt flash rhce to slash opt slash VDO. Copying, please wait. We have given a hyphen arv because there are directories, there are files, there's a chance for archive files. That's the reason hyphen arv. You might be knowing it. Okay, copied. Now what you have to do is first check ls slash opt VDO. Yes, RHCE directory is visible. Okay, visible. Okay. So now what I'll do is I'll check how much space it is, utilized on. You just give, DU. DU stands for disk usage hyphen H slash OPT VDO RHCE. Okay, it's showing to not two. Okay, but okay, you should not check from here. You have to just give, a video status command, video status hyphen human readable. From this earlier, okay, earlier, you know what, 4 GB was used. Now you see 4.1 GB. And earlier 6 GB was free. Now 5.9 GB. But we have, it should be 4.2, means 200 MB, right? It should be 4.2, understanding, but it's 4.1, means less than 200 MB is utilized. But you please try to understand total size of, okay, that RHC directory is 202 MB, but only less than, okay, 200 MB is used. So since we are giving human readable, we can't come to know how many exactly how many MBs, okay, is the size, understanding, because okay, it will show in bytes. That's one trouble. Okay, now what I'll do is I just want to save. I'm going to store same, I'm going to copy same directory 2-3 times. Okay, now 4.1 MB only used, right? I'm going to copy same directory again 2-3 times. Okay, I'll just say like cp-arv this directory to VDO. Okay, in like I'll say like C1 means copy one. It will create a directory, okay, called C1, and it will, okay, paste in that. So I'm going to copy same, okay. When you are testing, you can check with movie or something, okay, but here movie copy will take time. That's the reason I'm just trying with some 200 MB. You try with some video, like, maybe 1 GB video, copy multiple times, okay, then you can understand. See, this is a second copy, and I'll just, try to copy once again, remove V, okay, but here I'll just give C2, second copy. Okay, copy. So I've removed V, so it will not show the progress on screen. I said it's a matter of 40 minutes, right? Anyway, we will discuss troubleshooting tomorrow. Don't miss tomorrow's chapter. Okay, troubleshooting of disk and storage storage devices. Okay, so totally 3 copies, right? 3 copy means 600 MB must be used. 600 MB. 600 MB. Earlier it was showing like 4 GB is used. It should be 4.6, but let's see how much is showing. Human readable command, check human readable. It's showing again 4.1 GB only. Again, you keep multiple copy because same file copying multiple times, right? Understanding. So what will happen is when you are storing data, when you are trying to write data on a disk where data deduplication is enabled, okay, data deduplication algorithm will receive the data from the, okay, data, and it will just divide into bit streams, and equal bit streams are stored only once. So also it will match with an existing bit streams, existing data, understanding, it will match. It will first make bit streams, and okay, it will just, match bit streams of same file, and later it will match with an existing files. So finally it will store only equal bit streams are stored only once. So this is what, okay, optimization technology. Now I have to show you how do we remove video disk. Okay, either you unmount and remove, or you can forcefully remove. It's already mounted, right? So either you can unmount and, okay, remove, otherwise you can remove it forcefully. Okay, so anything is fine. So I'll just remove, like I'll just say, and also there is a command to check whether data deduplication and compression is enabled or not. Okay, so that is video status, I think. One second, let me check video. Yeah, video status. I'll just say like hyphen name and video 1. So will show you complete. Yeah, it's like, it's showing complete status. I just want to know whether compression and deduplication is enabled or not. Whether compression and deduplication is enabled. So then you can give what, you can just grep into this, right? Grep. Okay. Just like, let me check compression. I'm just trying to search for this particular expression in this list. It says compression is enabled. Same way you can just grep into deduplication. Okay, deduplication also enabled. So if you remove compression and deduplication, if you remove deduplication, it will become normal disk with compression. If you remove compression, it will come like a normal, okay, partition, regular partition. So no one will do that because we are using this technology for optimizing the space. Okay, optimizing the usage of the, storage space. Finally, I'll show you how do we remove VDO disk. Just, give again VDO list. Must practice, okay, just for at least for, passing exam. And I'll just say like, now it is already mounted, it is in use. What I'll do is I'll just use remove. I've told you either you can unmount and remove, or you can remove, okay, when it is in mounting state. You have to just use, hyphen force option, force hyphen name of the video is VDO1. So this is how we, okay, it's removed. Now check list. No video disk available. Check LSBLK. Your disk STA is normal. Okay, partitions, everything removed. So this is what VDO. Okay, we are supposed to finish within 40 minutes, but anyway, took 1 hour. So I think no questions. Please practice. Okay, just practice what I showed. Enough. Okay, and I'll send the PDF now that contain complete steps. Just read some initial theory just to understand. Okay, try to understand what is data duplication. This is frequently asked interview question because in storage, especially in storage interview, they will ask you what is data duplication. And also if you want to know more about it, I'll just share a small, I'll just share a link, Microsoft article link, just to try to read it. You will really understand from the article because they have just, explained with animation. So easy to understand. Okay, so ask if questions. If no questions, we will meet tomorrow. I have another session.
So, sir, the data deduplication is available in those client machines? No, no.
What?
Data deduplication, that feature is available in Windows client.
Windows client operating system doesn't have this data deduplication. It's available only in Windows Server. Okay, that too from Server 2012 above.
Okay.
Introduced in 2012 server first. So I'm using here 2016 server, so it is there in 16 server also. But try to understand, you cannot apply data in case of Windows, you cannot apply data duplication on root drive, root partition. Because if you apply on root partition, it will really badly impact your operating system boot process. And also you try to understand why, who will store, important data on C drive. We will always store data on, some other drive. In offices, we will store data in data centers and enclosures, right? So that's the reason this technology is not for, your operating system partition or application partition. It is for data partition. Okay.
Okay.
So, okay, then that's all. We will meet tomorrow. Tomorrow we will discuss troubleshooting. It's very easy. Okay, maybe 30 minutes. We can, okay, also I'll explain journaling. Journaling is really very important interview question. I've told you recently I've attended one TCS interview. They ask in, journaling, really. Journaling is very important, so don't miss it. We'll meet tomorrow. I have another session now. Okay.
Okay, bye.
Yeah, bye. Thanks to all.
Thank you. Bye.
Welcome.